Hello class, I hope you are having a wonderful day. Right now I'd like to take a look at the resolving vectors assignment. So I would like to complete 3 of the problems with you. Now before we get started, make sure that your calculator is in degree mode. A lot of the graphing calculators default to radian mode, so go into your settings and just double check that your calculator is in degree mode. So let's go ahead and get started. So what I'd like to do is complete problems 4, 5, and 6 with you. So on problem 4, the first thing we need to do is ask ourselves, so we're given our vector magnitude of 25 meters, and we're also given the direction of 70 degrees. But this is with respect to the y-axis. And remember, the first step is to always ask yourself, do I have the reference angle? Well, in this case, no, we do not. So our reference angle, so the degree measure between the x and the y-axis here in the 4th quadrant is 90 degrees. So 90 degrees minus 70 degrees, we're going to have a 20-degree reference angle. All right, so what let's do next is go ahead and redraw our triangle, and we're going to label the x and the y components. So here is my vector magnitude, and that's my hypotenuse, so 25 meters. We have an x component, and then we have a y component, and our angle with respect to the x-axis, also known as a reference angle, 20 degrees. So what we're going to do is, let's first start out with x. We know that the base equation is cosine theta is equal to the x component divided by the vector magnitude or the hypotenuse. And we're going to isolate our x component by multiplying by hypotenuse on both sides of the equal sign. So multiply by hypotenuse here. And on the left side, we're going to multiply by hypotenuse. Now on the right-hand side of the equal sign, the hypotenuse will cancel. So we have isolated our x component. So x is equal to our hypotenuse, or our vector magnitude that we have, times cosine of the angle theta. This is going to be, well, 25 meters. We're going in a positive x direction since we are in quadrant number 4. So a positive 25 meters times cosine of 20 degrees. So go ahead and take out your calculator. Once again, make sure that your calculator is in degree mode. So what we have is 25 cosine 20 degrees, and this is going to give us 23.5 meters. And don't forget your units here. Okay, now let's talk about the y component. Now we're in the 4th quadrant here, so that means we are traveling in a negative y direction. So we need to apply that negative sign to our vector magnitude to show direction, that we're traveling in a negative y direction. So what we have, our base equation is sine of the angle theta equals the opposite side length. So the opposite side with respect to our angle is our y component. So y divided by our hypotenuse or our vector magnitude. So what we're going to do is multiply by hypotenuse on both sides of the equal sign. On the right-hand side of the equal sign, hypotenuse cancels. So I have y equals our vector magnitude or our hypotenuse times sine of the angle theta. So I have a negative 25 meters. And remember, this sign is negative because we're talking about the y component, and our y value in quadrant 4, right here, we're in quadrant 4, is negative. Okay, so we have to apply the negative sign. Okay? Negative 25 meters times sine of 20 degrees is going to give me negative 8.55 meters. when we start at the origin and we travel 25 meters, 20 degrees south of east, we're at this point here. And so what we've just done, vector resolution, breaks our vector down into the x and y components. And so what we're doing is we are traveling a positive 23.5 meters in a positive x direction, and then we are traveling in a negative y direction, 8.55 meters. Okay? All right, so I've labeled it here. Now we don't need to put the negative sign here because we have our vector arrow going down in a negative y direction, okay? But in our answer, we do need to say negative 8.55 meters, okay? Let's move on to number 5. On number 5, first thing we need to do is ask ourselves, do we have the reference angle? Well, the answer is no, because right here we're referencing the y-axis. That's a big no-no. We don't do it. Okay, so 90 minus 55 degrees is 35 degrees. Okay, let's redraw our triangle using the reference angle. So we have an x component, and we can already see that our x component is going to be negative because we're traveling in the negative x direction. We are in quadrant number 3. So there's our x, and right here is our y, and our reference angle is 35 degrees. Okay, so let's go ahead and solve for the x component. So what we have, our x component. Now our base equation, we always start out with cosine theta is equal to the x component divided by the hypotenuse. Now we've isolated the x component several times before, so I'm just going to start using this equation here. X component equals the hypotenuse times cosine theta. Okay, now what we're going to do is plug in the value for hypotenuse. But right here, this is 14 meters. We're in quadrant 3, and so we're traveling in a negative x direction. So we're going to say negative 14 meters times cosine angle theta, which is our reference angle. That is 35 degrees. So on your calculator, negative 14 times cosine of 35 degrees, we get negative 11.5 meters. Okay, that is our x component. Now our y component. Let's go ahead and look at the triangle that we've drawn. We know that the y component will be negative 2 because we're in quadrant 3, and you see that the arrowhead is pointing in the negative y direction. So we're going to have a negative y value. Y equals hypotenuse times sine of the angle theta. So hypotenuse, we need to apply the negative sign to it because we're in quadrant 3. We're going in a negative y direction. Negative 14 meters times sine of our reference angle, which is 35 degrees. Now you get negative 8 meters. Okay, so negative 8 meters. All right, let's go ahead and take a look at number 6 here. On number 6, first thing we have to do is ask ourselves, do we have a reference angle? Well, no, we do not. We have 37 degrees. So we know that the angle measured between the x and the y-axis here is 90 degrees. So 90 degrees minus 37, that's going to give us 53 degrees. So our reference angle is 53 degrees. Okay, so let's redraw the triangle. The magnitude of our vector is 23 meters. have an x component, and we have a y component. And our reference angle here is 53 degrees, okay? So x component is equal to our hypotenuse times cosine of the angle theta, and that's our reference angle. So we have 23 meters times cosine 53 degrees. So 23 cosine 53, and it's positive because we're moving in a positive x direction. Right here we are in quadrant number 1. So this is going to be 14.78 meters, and this is positive. Okay? Let's take a look at the y component here. We have y component is equal to the hypotenuse times sine of the angle theta. Our hypotenuse is 23 meters, and we need to ask ourselves, is this value for the y component positive or negative? Well, we are in quadrant 1, and we know all y values in quadrant 1 are positive. So positive 23 meters times sine of 53 degrees. So the y component is going to be 18.4 meters. So don't forget to include your units on there. Okay, if you have any questions about these 3 problems, as always, please give me a call or send me an email. I will be more than happy to help you. I hope this video has helped, and I hope you have a wonderful day.